From Calculus, 9th edition by James Stewart. In this episode, we will learn Chapter 16, Section 16.8, Stokes Theorem. I assume you have read the theory in this part of the book. I would like to read about George Stokes. Stokes Theorem is named after the Irish mathematical physicist Sir George Stokes, 1819–1903. Stokes was a professor at Cambridge University. In fact, he held the same position as Newton, Lucasian Professor of Mathematics, and was especially noted for his studies of fluid flow and light. What we call Stokes Theorem was actually discovered by Scottish physicist Sir William Thomson, 1824–1907, known as Lord Kelvin. Stokes learned of this theorem in a letter from Thomson in 1850 and asked the students to prove it on an examination at Cambridge University in 1854. We don't know if any of those students was able to do so. I am very glad that I finally understand Stokes' theorem. So, line integral over curve is equal to surface integral. I will not explain the theory about Stokes' theorem. Instead, I will solve example 1 in my current episode. Today is February 11th, 2023. This is my 227th episode for C++ 17 2023 Good article OpenGL TBB Balkan. This is my 57th episode for vector calculus. Stokes Theorem 1. Line integral equals surface integral. Please understand, I updated C++ library extensions. If my source code does not work on your machine, you need to download updated C++ library extensions. I assume you have watched my previous videos listed here. Otherwise, you may not understand my current and future sessions. Without further ado, let's get started. Open up Visual Studio Code from CPP 17-20-23 parallel. Select empty space. Click this button to 27. Stokes. Hit enter. Click this button. Stokes.cpp. Hit enter. Ctrl V. I will delete welcome window. I would copy and paste these links. Control Home. In two of our previous videos, we implemented delta operator, also gradient, divergence, and curl operator. If you haven't watched my previous videos listed here, you may not understand my current and future sessions. I will fold it up. Then Calculus by James Stewart. The example: evaluate f.r over curve C, where f is defined like this, and C is the curve of intersection of the plane y plus g equals 2, y plus g equals 2, and the cylinder x square plus y square 1, x square plus y square 1. This cylinder. Orient C to be counterclockwise when viewed from above. This boundary curve C should be oriented counterclockwise when viewed from above. I will arrange like this. We will solve this problem in three different ways. Left-hand side is f.dr along the curve C counterclockwise. This is the first method. void solve. Example 1. Line integral. Int main, copy the function name, paste it in function main. We need using namespace, CPG, numerical analysis, commands. Using namespace, CPG, operators and constants. In the figure 3, we need to parameterize curve C, counterclockwise orientation, like this. R, CNA, create BCTR 3D. On the XY plane, theta, return SED cosine theta. Because x square plus y square equals 1 is unit circle. Copy, paste. This is sine theta. Copy, paste. Now the height of this curve is represented y plus z equals 2. Remove trailing, comma, y plus z equals 2. From this, z equals 2 minus y. From this, z equals 2 minus sine theta. So copy this, paste it here. STD sine theta. These are parameterized. The curve C counterclockwise. Now we define vector f equals minus y square I plus xj plus z square k. Or f CNA create BCTR 3D, semicolon. Please understand, we should take three parameters, or x, or y, or z, x component, negative y square, return negative y times y, comma, copy, paste. This should be comma, comma. Now j term is x, so we return x. I will arrange like this. Copy, paste. Now k term, z square, so g times g. Remove trailing, comma. We defined parameterization R, also vector f. We can do line integral like this, or C R line integral. We pass f, then the range of theta. In this figure, the theta is angle from x-axis around the circle at the bottom. So it should be 0.02 times pi. This is our line integral. Auto answer in this book, the answer is phi. CNA print answer. Line integral C answer. With this, open up any compiler. dir cd 227 Stokes clang SED C++20 Stokes.cpp ltbb 12 oc.exe hit enter. CLSC, our numerical solution is correct. If you do not understand how I implemented line integral, then right-click, go to Definition. Here, you can find the source code. If you don't understand, I will give you some explanation. This part can also be evaluated like this. Or C, CNA, integral. We have to pass the integrand. F, R, this is dot product. R, derivative. This is dr. R dot derivative represent dr. Here, please look at my mouse cursor. We have to pass r as parameter to f because this vector f takes 3 parameters. Then 0.02 times pi. This is equivalent. With this, we can build again. CLSC. The result is the same. So this line integral performs operation like this. Now we will evaluate surface integral curl f dot ds over surface s. This surface s is this surface, the top of this cylinder. If we check line integral equals surface integral, we can confirm Stokes theorem is correct or not. Now copy this function, copy, paste, scroll up. I will rename surface integral. Copy this function name, copy, Ctrl N, paste here, scroll up. Now we have to parameterize our surface. We will parameterize this surface. To be a surface, we need 2 parameters. Or radius. This radius runs from 0 up to 1 because this is unit circle. Then x should be radius times cosine theta. In the same manner, or radius, y should be radius times sine theta. Now this part, or radius, y is radius times sine theta. So it should be radius times sine theta. Copy this, paste it here. These are parameterized surface S. Please compare this parameterization with this parameterization. This vector R parameterized the curve C counterclockwise, the boundary of this surface S. In this case, we take 1 parameter. This theta is good enough because our radius does not change. It is like 1 times cosine theta, 1 times sine theta, 1 times sine theta, because we are interested in this boundary curve. However, in this case, surface integral, these are parameterized the surface. We need to be able to render the internal points of this surface as well. So we need 2 parameters, radius and theta. This part is the same. Now we are performing double integral. Here, this surface integral, we have to compute curl over f, or curl f equals del r, this is cross product f, curl of f. So we evaluated curl f. Now, or r, t. From r, we take derivative. it returns two vector, two tangent vector in the direction r, in the direction theta. Now we create curl f dot ds. ds can be computed. Or ds r cross r t. This is cross product. This ds represent this ds. Now or c cna integral. It should be double integral because we are integrating over surface S. It should be double integral. Our integrand is curl f. Curl f. We have to pass R because f, members of f are taking 3 parameters, but we are performing double integral. So we have to pass R, which takes 2 parameters. Then this is dot product. This dot product can be dot ds. Curl f dot ds. Curl f dot ds. Then SED make tuple. We will specify limits of radius. In our case, the limits of radius, the boundary of this surface S, is C. Our radius runs from 0 up to 1. So 0.0, 1.0, comma, radius limits. We are performing double integral. Our parameterization R takes 2 parameters, radius and theta. Theta runs from x-axis to pi to make full circle. So it should be 2 times pi. This is theta limits. Now we have to specify the meanings of these limits. Theta comes last. So dt, then radius, dr. This is our integration. Once again, although answer is in this book, answer is 5. Then CNA print answer surface integral C answer. So we completed our code. Now we build again. CLSC. Our surface integral matches line integral. This proves Stokes theorem is correct.